Welcome to Session 3 of Unit 4 in learning the course Design and Analysis of Algorithms. In our previous sessions, we learned about the general method of backtracking and one of its applications, N-Queen's problem. In our today's session, we are going to see another application of backtracking, which is nothing but sum of subsets problem. The main objectives of this session are to understand sum of subsets problem, to solve the sum of subsets problem by following backtracking algorithm design technique. The learning outcomes of this session are, by listening this session, one can understand what is sum of subsets problem and able to follow backtracking algorithm design strategy to develop algorithms for solving sum of subsets problem. The topics that we are going to discuss in this session are problem statement, state space tree, and algorithm which is developed based on backtracking algorithm design strategy. Coming to the problem statement, what is sum of subsets problem? Given a set of elements and an integer value. Here we are given a set of elements and an integer value. Subset sum problem or sum of subsets problem. We can call it as subset sum problem or sum of subsets problem. The problem is to find subset of elements that are selected from a given set whose sum adds up to a given integer k. Let us say here I given a set of elements s is equal to s1, s2, s3, so on, sn. Here I given n elements in that set and also given an integer value k. Here, what is sum of subsets problem? The sum of subsets problem is to find a subset for this set. Here, the sum of subsets problem is to find a subset for this set by adding the elements of that subset. The sum should be equal to given integer k. That is, we are going to find a subset of this set, which is nothing but, suppose let us take s1, s2, sj and so on, sk. We selected some elements, definitely this j and k less than or equal to n, and the sum of these elements plus sj plus so on, sk should be equal to k. That is the given integer. So like that we need to find the subsets for the given sets, the sum of whose elements adds up to the given integer k. Now here the constraints or the important points that we need to consider in solving this problem are: the set contains non-negative values. Here the set what we given should contain non-negative values. All the positive values should be present in that set. And the input set is unique. That is, every element is unique in the given set. No duplicate values are present in the given set. The time complexity of solving the sum of subsets problem is big O of 2 power n. The time complexity of solving this sum of subsets problem by following backtracking method is big O of 2 power n. Now coming to the state space tree, how to construct a state space tree for solving this sum of subsets problem by taking, here I am going to explain that construction of state space tree by taking an example. Let us see here the given set is S is equal to 3, 5, 6, 7. 4 elements are there. All the 4 elements are positive integers and also there are no duplications. And also given an integer value k whose value is 15. Now, how to construct state space tree to get the solution for this problem? That is, to get or to find the subset which sums up to the given integer k, which is 15. Now, let us see here the root node starts with 0. Always root node starts with 0. Here I already said you while we are explaining about state space tree, we can construct the state space tree in BFS way or in DFS way, that is breadth first search way or in depth first search way. In both the ways we can construct the state space tree. Now here we are going for depth first search in constructing this particular state space tree. Now let us see it. So here 0. One more thing we need to consider before constructing the state space tree for this problem is we need to arrange all the elements in increasing order. So here the given set, the elements may be present randomly, but before solving this problem for constructing the state space tree, first you need to arrange all the elements in increasing order. Here in this given set, all the elements are already arranged in increasing order. So here I am considering directly the given set. Now the first node, how to generate the first node in state space tree? Let us see. So here the first node is generated by considering the element 3. With 3. Now that is, we are considering the element into the subset. Then what becomes the sum? The sum, initially sum value is 0. Initially we are taking sum value as 0. Now we are considering an element 3 into the subset. So initial sum 0 plus 3. Now the sum becomes 3, which is less than 15. That is, we can add some more elements to the subset. Now with 5, here we are adding the next element 5 into the subset. The sum becomes, earlier sum is 3, now the sum becomes 8. Now with 6, if I added the sum, it becomes 14. With 6 it becomes 14. The sum becomes 14. But if you add the next element, which is nothing but 7, 14 plus 7, which becomes 21, which is greater than the given integer. So here from this path we did not get the solution. So if I add 6, then if I add 6, I did not get the solution. If I add 7, here also it exceeds the given integer value. So I am not getting solution in this path. So I am backtracking the process. Without 6 we are considering. Without 6 what the sum becomes? 8. Now here without 6 we are doing the next remaining element. So here in this path with 3, with 5, that is we added 2 elements. Without 6, that is we discarded 6. Next we are adding the next element 7. Here the sum becomes 15, which is equal to the given integer. So we find a solution. What is the solution here? The subset that we find is 3, 5, 7. The subsets that we find is 3, 5, 7. That is how to write the solution for this one. How to represent the solution? Here the solution becomes, since we considered 3, in the place of 3 it becomes 1. So that is, if I represented any element value 1 means we are considering that element into the subset. If we are representing any value 0 means we are not considering that element into subset. Now here 5 becomes 1 and 6, we are not considering 6. In the place of 6 it becomes 0. In place of 7, since we are considering 7, it becomes 1. So the solution for the given problem is 1, 1, 0, 1. That is 3 is considered, 5 is considered and 7 is considered, 6 is not considered. Now here we already know that the backtracking problem, after finding one solution, it continues the process to find the remaining solutions which are present in the process. Now here again without 7 it goes for backtracking. Without 7 again it has 8. No more elements in the set to add. Since 8 is less than 15, in this path also we cannot get the solution. So it is backtracking the process to one more level up. So without 5 the sum becomes 3. With 6 the sum becomes 9. If I add 7 it is greater than 15. So I cannot get the solution in this path. So we are backtracking the process and we are taking without 6. Here I already taken without 5, without 6. Only the element which is present is 7. If I add 7 to 3 it becomes less than 15. So in this, since no more elements are there in the set, in this path also we did not get the solution. So since all these ends becomes dead ends, we are backtracking the process to one more level up to the root node. Here without 3 we are considering the sum becomes 0. So with 5 we are considering the sum is 5. With 6 we are considering the sum is 11. Only one more element is there, 11 plus 7, which becomes 18, which is greater than 15. So we did not get the solution in this path. Now here we are backtracking the process. Without 6 we are considering the one element only. Here without 3 and without 6 we are doing, that means only with 5 is added, and only one more element is there to add, 5 plus 7, which becomes 12. No more elements are there in the set, so we cannot get the solution in this path also. So we are backtracking the process without 5. So with 6, if we go for with 6, the sum becomes 6, and if we add 7, which becomes less than 15, so we did not get the solution. If we go for without 6, here also the sum becomes 0. If you go for with 7, no more elements are there, only sum becomes 7, which is less than 15. Here also we did not get the solution. So the only one solution that is present for this problem is this one, 3, 5, 7, whose sum is 3 plus 5 plus 7, whose sum is 15, which is equal to given integer. This is the process of constructing state space tree for finding the solution of sum of subsets problem. Let us see the algorithm for solving sum of subsets problem. Here this gives the algorithm which is developed based on backtracking method. Now let us see what are these terms. Here algorithm sum of subsets, we are passing 3 parameters to the algorithm. Those 3 parameters are S, K, R. S is the sum of all elements in the the sum, what the sum that you want to find. S is sum, and K is the number of node number. Tree node number is represented with K, and R is the sum of all elements in the given set. S is the sum, initially its value is taken as 0. K is the node number, what the node that we are representing, that node number, and R is sum of all elements given in the set. Initially we are taking x of k is equal to 1. Initially we are taking x of k is equal to 1. If sum plus w of k, that is weight of k, which is nothing but the value which is present at the position k, so is equal to m, then write x1 to m. 1 to k, that is if the sum value, initial sum value, and what the element we taken as 1, if its weight, if we add these two values, if it is equal to the given integer, that is we find the solution. So we need to write the solution vector. We need to write the solution vector. Else if s plus w of k plus w of k plus 1 less than or equal to m. So if s plus w of k and plus the next element weight of the next element, that is s plus w of k is not equal to m, it is less than m, and we are adding the weight of the next element. Even after adding the next element also, if the sum is less than or equal to m, we call the sum of subsets, again recursively we are calling sum of subsets algorithm for s plus w of k, k plus 1, r minus w of k. That is x of k is added. For k plus 1 we are calling the sum of subsets problem. Now if s plus r minus w of k is greater than or equal to m and s plus w of k plus 1 less than or equal to m, then x of k is equal to 0. So even after adding w of k plus 1, if it is less than or equal to m, in this case that is x of k is completed, x of k plus 1 is also completed. Even after adding x of k plus 1 also we are not getting the integer value. In that case, since we are not getting the solution, we made x of k as 0 and we call the algorithm for k plus 1. That is, by including k we are not getting the solution. So we are discarding k and we are calling algorithm for k plus 1. So this is the algorithm which is developed based on backtracking process to find the solution of sum of subsets problem. Now let us see the construction of state space tree based on this algorithm. Let us see the process. Here, for explaining that the same example I have taken what we explained earlier. The same example I have taken here. The set S is equal to 4 elements are given. Those 4 elements are 3, 5, 6, 7 and the integer value given is 15. Now, initially, what the S, K, R becomes. I already said you that S is the sum value initially whose value is 0 and K is 0. K becomes the node number. Initially its value is 0 and R is the sum of elements in the given set. Here 4 elements are given 3, 5, 6, 7. The sum of elements is 21. R value becomes 21. So the first node in the tree becomes 0, 0, 21. S, K, R 0, 0, 21. Now after that how to extend the tree? So always the root node becomes the promising node. So from the root node we need to generate the child nodes. How to generate the child nodes? Let us see. Now x of 0 is equal to 1. Initially we are taking x of 0 is equal to 1. That is the first element is 1. Now S plus W of K, that is S initially sum is 0, W of 0 whose weight is 3, 0 plus 3 which is less than 15 and R is equal to 21 minus 3. Since we added 3 into the subset, we need to subtract 3. What the element we added into the subset, that is to be subtracted from R. So we are subtracting 3 from R which becomes 18. Now the next node becomes 3, 1, 18. Here the node number is 1, sum value is 3 and R value becomes 18. Now next x of 1 is equal to 1. So first x of 0 is 1, next x of 1 is equal to 1. Now here what becomes the sum value? S plus W of K is equal to 3 plus W of 1. 3 plus weight of the first one element which is nothing but 5. 8 which is less than 15. Since it is also less than 15, we can generate the child, that is we can add one more element and R value becomes 18 minus 5 which is 13. Now the next node is 8 to 13. Here sum value is 8, node number is 2 and R value becomes 13. Now the next one, x2 is equal to 1. Now what becomes the sum value? Already initial sum value, earlier sum value is 8, now 6 is added, 8 plus 6, the sum value becomes 14 which is less than 15. That is, since the sum value is less than 15, there is a chance to add one more element and R value becomes 13 minus 6 which is nothing but 7. Now here the node becomes 14, 3, 7. Now, if I add S plus W of K plus 1, that is next element. So, that is next element is 7. 14 plus W of 3, which is W of 14 plus 7. 21, it becomes 21. So, it is since it is greater than 15, there is no chance to add this element 7. So, here the node becomes dead node. So, hence, we take x2 as 0. We take x2 as 0. So, that is we are backtracking the process. Since we are backtracking the process, S value becomes 8, K value becomes 3 and R value becomes 13. Now, the next node is 8, 3, 13. Now, we are continuing the process. Now, let us take x3 is equal to 1. If x3 is equal to 1, the sum value becomes, the initial sum S is 8. Plus now the added value is 7 which becomes 15 which is equal to the given integer and R value becomes 6. Now here the next node is 15 plus 15, 4, 6 which is the solution. That is, what is the solution we are getting? x0 0, x1 1, x2 0 and x3 1. That is 1, 1, 0, 1 is the solution for the given problem. So, this is the way of constructing state space tree based on algorithm. Right, I hope you all understood the sum of subsets problem and how to solve sum of subsets problem. Here, the sum of, I am going to summarize the concepts that what we explained in this session. In this session, we seen the problem statement of sum of subsets problem and how to construct state space tree to solve that particular problem in the general method, and we seen the algorithm which is developed by using backtracking method, and also we seen how to construct a state space tree based on that algorithm. So to assess yourself here, I given some questions. Please answer these questions. The first question is, what is a subset sum problem? Option A, finding a subset of a set that has sum of elements equal to a given integer. Option B, checking for the presence of a subset that has sum of elements equal to a given number and printing true or false based on the result. Option C, finding the sum of elements present in a set. Option D, finding the sum of all the subsets of a set. The next question is, under what condition any set A will be a subset of B? Option A, if all elements of set B are also present in set A. Option B, if all elements of set A are also present in set B. Option C, if A contains more elements than B. Option D, if B contains more elements than A. The next question is, state sum of subsets problem. Write backtracking algorithm for sum of subsets problem. Also draw the state space tree for the following sum of subsets problem. Here I given a sum of subsets problem and I also given an integer value 9. For these values you need to construct a state space tree. In preparing this presentation, I used the digital content from various public sources. This is used only for educational purpose and not for the commercial purposes. Thank you for listening the session.